Hello friends, welcome to CEC live lectures. So in the previous lecture we were talking about the different types of transmission media which are used to connect communication systems or computers on a data communication network, and we were talking about twisted pair cables. So we had seen that what is the purpose of twisted pair cables and why really we need to twist those cables across. So basically it is done to prevent any kind of crosstalk, right, between the wires, and to prevent the impact of noise, and to prevent signal impairment in case of this kind of wire. Now twisted pair can also be of two types, it can be shielded twisted pair and unshielded twisted pair. So commonly we say UTP and STP. Now shielded twisted pair is very less used, and this was basically designed and devised by IBM, right. So in this basically what they have done is that they have put a metal mesh or braided mesh covering that encases each pair of insulated conductors, right. So the metal casing, it further improves the quality of the cable by preventing penetration of noise or crosstalk, but it also makes the wire more bulkier and expensive because we are adding one more layer. So this shielded twisted pair is not used much outside IBM because they are the ones who started this also, and they are only using it. Most commonly used twisted pair cable is, of course, it still remains the unshielded twisted pair cable, in which there is no metal braiding. As you can see in this diagram also, there is no metal shield in the unshielded twisted pair cable, and it is a simple two wires, insulated wires, which are twisted along them, and there is a plastic cover in which they have been encased. So this is a very simple transmission media, very economical transmission media, which has been used in multiple applications earlier also. And this is rather the cheapest of all transmission media which are there. So if we look at performance wise, so it's already discussed that there is a problem of crosstalk or noise in case of twisted pair. The other thing is, when you measure the performance of a twisted pair cable, we have to compare the attenuation with the frequency and the distance. That is, when you increase the frequency, the attenuation measured in decibels per kilometers will also sharply increase. When your frequencies go above 100 kilohertz, then the attenuation problem will be even more sharper, right. So therefore twisted pair cables, they have this serious problem of attenuation, that is the drop in signal, and also of crosstalk or noise, right. But still these cables have been used widely in telephone lines to provide voice and data channels. They are also being used in the local loops, that is the line which will connect the subscriber to the central telephone office, which is commonly consists of unshielded twisted pair cable. So a large part of the application of twisted pair is limited to the telephone data networks and telephone voice networks. Now DSL lines that are also used by telephone companies, which provide high data rate connections, they are also using high bandwidth capability unshielded twisted pair cables. And some local area networks within simple, when you want to build a simple local area network, then also twisted pair cable may be the transmission medium of choice. But other than this, for building high quality computer networks, now these twisted pair cables are hardly used. The next type of cable that we need to look at is the coaxial cable. Now coaxial cable, the structure is much more complicated, and it is got further more layers in it as compared to the twisted pair cable. So coaxial cable basically it has got a central conductor and a single, basically it's a single wire, generally it is made up of copper, and on top of that you have a layer of insulator, and on the insulator there is another layer of outer conductor or shield, right, and then the shield is further having an insulator which is packed in a protective plastic cover. So we can see that there are actually, the wire has been encased in 4 layers. So there are 3 layers of insulating plastic, and there is 1 layer of conductor shield, right. So this is a very robust kind of wire which has been built, and the main purpose of having the outer conductor or the shield is twin purpose is there actually in this. So basically these signals are these coaxial cables, they are used for carrying signals of higher frequency ranges than those in the twisted pair cable, right. So coaxial, there is a central core conductor and the outer metallic wrapping, it is basically definitely it is a shield against the noise, as we have already seen that in case of twisted pair there is so much problem of signal impairment and crosstalk and noise. So this outer metallic wrapping will help that also, and the second conductor, it will also act as a second conductor. So therefore the circuit has to be completed, because you need two wires to complete the circuit. So this metallic casing which has been put outside the insulator is also going to act like a second conductor. So therefore now in case of coaxial cables, the attenuation of course is much higher and then in case of twisted pair cable, because the drop in signal is there, but they have a higher bandwidth, they can carry signals of much higher frequencies, but the signal will weaken rapidly, and therefore there is a constant need of putting frequent repeaters on the way of the signal. Why? Because the signal because the single wire is carrying it, so therefore and high frequencies are being carried out. So when you have a high frequency signal moving across the wire, then the attenuation increases. Now applications of coaxial cables, they are widely used, okay, they are widely used in analog telephone networks, okay, where a single coaxial network could carry 10,000 voice signals, okay, and then later on it was used in digital telephone networks also, where a single coaxial cable could carry digital data up to 600 Mbps. So coaxial cables have been widely used in case of cable TV networks, in case of telephone networks also, both analog telephone networks and digital telephone networks, and in cable TV operators of course they use it. And there is another way in which these are being used, that is a hybrid kind of architecture is being built on this. So that is also an important area where coaxial cables have found, where a network is built, a cable TV network and the home internet data services networks are being built, which are using both a combination of fiber optics and the coaxial cable. Another very common application of the coaxial cable is in the traditional Ethernet LANs, right, because of high bandwidth and therefore the data rates are also high, and this is a chosen medium for digital transmission which is used in Ethernet LANs, because Ethernet LANs, they are geographical their geographical size is small. So therefore in that case not much need of repeaters is there. So therefore these are very commonly used. Also they are they are slightly more expensive than the twisted pair cables, but the performance the benefits in the performance which one gets are far more there. So the third type of guided medium which we would like to see is the fiber optic cable. Now fiber optic cable, the name itself suggests that it is going to be a very fine wire just like a fiber, and it will be optics means something related to light, right. So this will be using light as a medium for transmission of information or data signals, right. So optical fiber or the fiber optic cable is actually made up of glass or plastic, and it transmits the signals in the form of light. So this is the it is the in guided media, this is one of the best transmission media which is used, and it to overcome the problems of twisted pair as well as coaxial cable. Now when we are talking about light as a medium for transmitting data, it's important to understand some basic phenomena related to light. So it is well known that light always travels in a straight line, as long as it is moving through a single uniform substance. So when the substance will change, then light will the light will change its path, or the light will bend, right? Like we all must have done this simple experiment, that when you place some object in water, right, so and you look at that object, so that object appears to be bent. Why is this happening? Because light is moving in air, and then when it enters the water, so there is a change in medium from air to water, the ray is changing its medium, so therefore the path of the light is also changing. So from straight line it will change its path, right. So this is an important phenomena which is used in case of transmission using the fiber optics. So if you look at this diagram, so in this case we see that this ray of light is travelling through one substance and it suddenly enters another substance of different density. Say for example, we are taking air and glass. So air is less dense and glass or plastic is more dense, right. So then the ray will change its direction. So if you see here, we talk about three things. We talk about angle of incidence. So angle of incidence basically is the angle which the light ray it creates with the perpendicular plane which is there. So if the angle of incidence is less than the critical angle, now critical angle is something which is related to, or which is which is determined for a particular medium. That is, for each medium the critical angle will be different, right. So if the angle of incidence is less than the critical angle of the medium, then we say that reflection has occurred. And if the light ray it moves from a less dense material into a more dense material, but the light ray does not deflect, but the angle of incidence and the critical angle are the same, then we say that refraction had occurred. So in both the cases, that is when angle of incidence is less than the critical angle or angle of incidence is equal to the critical angle, we say that refraction has occurred. But there is another situation where we say that when the light ray it bends and it moves in the same direction, right, that is the angle of incidence is greater than the critical angle, then we say that reflection is occurring. That is, the light ray is changing its path, it is bending and it is moving inside the other plane, right. So basically the angle of incidence, or the angle which the ray is making with the line perpendicular to the interface between the two substances. Interface means the point where the two substances are meeting, right. It is less than the critical angle, then the ray is said to be refracting, or it is, we are saying that it is moving closer to the surface. And if the angle of incidence is equal, that is the second case, if the angle of incidence is equal to the critical angle, then also the light bends along the interface, right. If the angle is greater than the critical angle, then the light ray reflects, that is it makes a turn and it travels again in the denser medium, it comes back into the same medium. So therefore we understand from this that we want that the angle of incidence should be actually it should be actually greater than the critical angle of the medium, so that the light ray will reflect. We always want that the angle of incidence remains greater than the critical angle in case of an optical fiber. Now the critical angle basically, as I already discussed, it is a property of the substance. So its value will vary from one substance to the other, and optical fibers will use this reflection property of light, so that the light can remain inside the channel. You do not want the light ray to be refracted and going out of the medium, going back into the less dense medium. You want that the ray should be reflected and it keeps back, it keeps within the channel. So a glass or plastic core, therefore you have surrounded it, you surround it by a cladding of less dense glass or plastic, because what will happen when there is an interface from a more dense to a less dense, the light ray will reflect and it will come back inside the channel only, it will not go outside, because there is a difference in the density of the two materials. Therefore, because, and these media are chosen carefully, that there should be difference such that the beam of light moving through the core, it is reflected off the cladding instead of being refracted into it, because we want that the light ray should remain within the core, it should not go outside, right. So, if you look at this picture also, it is made very clear. This is the picture of an signal, how it is travelling inside an optical fiber. So, we have a sender who is sending the signal. There is a cladding which is put outside the core. So, this cladding is also made up of glass or an plastic, but it is less dense than the inner core. So, the inner core is more dense material, the outer cladding is less dense material. So, when the ray of light, it touches the interface between the core and the cladding, then it will be reflected inside the core again. Similarly, at the other end also the same thing will happen, because the cladding is less dense. So, the light ray will not be refracted, it will not go out of the cladding, but it will be again directed, it will be again reflected within the core. So, therefore, in this reflection, constant reflection occurs and the signal will be constrained to move within the core only, it will not go out. So, therefore, this is how we understand how the signal is going, the optical signal or the light is going to move from the sender to the receiver, right. Now, before we actually see that the signal is moving, we also need to understand the modes in which the signal will move inside the core, right. So, there can be two modes in which the signal moves inside the core. There can be a multi-mode and there can be a single mode. So, multi-mode basically we mean that there will be more than one signal which is moving across the core at any given time, and this can be done through two methods. One is the step index method or step index mode, and the other is the graded index or the graded index mode. And of course, the simple method is the single mode method, in which one signal will be flowing, one single signal will be flowing. So, this diagram sort of tries to explain what is multi-mode in case of step index and what is multi-mode in case of graded index. That is how the light signal is moving from the source to the destination and how the signal also undergoes a change. And in single mode, as we can see, there is a single signal which is moving out, right. Whereas, in case of multi-modes, we can see that multiple signals are going to be transmitted. So, let us look at each of these separately. In case of multi-mode, basically we say that multiple beams of light from a light source will move through the core in different path. Okay. Now, how these paths or how these beams will move within the cable will depend on the structure of the core. So, see, we are saying that initially we have understood that there is a core, outside the core there is a cladding. Now, within the core also how the signal will move, whether it will move in in a graded format or it will move in a step format, it will change its path suddenly, or there will be a smooth transition as the signal moves ahead in the core, is what we are trying to see here. So, in multi-mode step index fiber, this is a separate different type of fiber. What will happen is that the density of the core remains constant from the center to the edges. So, what will happen that the beam of light moves through this constant density in a straight line until it reaches the interface of the core and the cladding. So, this phenomena is very simple to what we have seen in the normal moving of the light signal within the core, because the intensity is the same, the core is the same all through. So, therefore, reflection will only occur when the light ray touches the interface between the core and the cladding. So, therefore, as soon as the light ray touches, the beam of light touches the interface between core and cladding, suddenly it will get reflected and it will change its path. Therefore, this is known as a step index, because the light ray is reflected as one suddenly it is getting reflected. So, at the interface there is an abrupt change due to a lower density, and this alters the angle of the beam's motion, right, because there is a lower density of the cladding. So definitely this is going to be reflected. The term step index refers to this suddenness, basically the suddenly this beam is changing. So this means what is the step index now, which contributes to the distortion of the signal as it passes through the fiber. So because of this change in the path, the sudden change in the path of the signal, it undergoes some change. A second type of fiber, which is known as the multimode graded index fiber. This decreases the distortion, because here what we are using the word is graded index. Graded index here refers to basically the difference in the index of refraction. Basically index of refraction is the way in which density is linked basically. So we are saying that index of refraction is different within the core at different points, which may mean that the density is highest at the center of the core and it decreases gradually to its lowest edge. So therefore what is happening, that instead of change in density occurring only at the interface between the core and the cladding, here the change in density is occurring within the core also, because the core is more dense at the center, and as it moves out it becomes lesser and lesser dense. So therefore there is multiple reflections which which are occurring in this light, in the signal. So in graded index fiber basically you have varying density, right, and therefore because of this the distortion in the signal is occurring throughout the cable, right. It is not like suddenly, but minor reflection is occurring throughout the signal in this case. In case of single mode, it uses step index fiber and high focused source of light that limits the beam to a small range of angles all close to the horizon. So again in this there is no change, and the light ray will move very simply in parallel to the horizontal. So the single mode fiber itself is manufactured with much smaller diameter than that of multi-mode fiber and with substantially lower density. So density basically is related to index of refraction. So the decrease in density results in critical angle which is close enough to 90 degree to make the propagation of beams almost horizontal. So in this case the propagation of different beams is almost identical, and therefore there are negligible delays. So negligible delays means that all the beams which are moving through the core, they will arrive at the destination at the same point, and therefore they can be easily recombined with little distortion to the signal. The signal will be distortion free as compared to the other signals. So if you look at this, this shows us the the structure of an optical fiber, and we can see that there is an inner glass core on which there is a cladding. The cladding of course is of glass or plastic only, and then there is a coating of Kevlar for strength. So Kevlar is basically a material which is used for making bulletproof jackets, etc. It's a very strong material, right. So therefore because the fiber is made of glass, the cladding is made of low density glass or plastic. So therefore for strength and for protection a very tough material has been given for this, and then you have the plastic buffer, and then there is another layer, and then finally you have an outer jacket. So therefore this is how the optical fiber has been comprised of, how it has been made. So if we look at the advantages, of course there is no attenuation, there is no heat, there is no crosstalk, no effect of noise. If you look at the disadvantages, definitely this is a more sophisticated network, so installation and maintenance will require trained people, the specific equipments are required. Cost wise also optical fibers are more expensive as compared to the other. Handling wise also these are more expensive. They find applications in wide range of areas, from cable TV to computer networks to different areas, and they are more and more they are becoming accessible. So this will be all for today's lecture. We will be continuing with another set of topic, that is unguided media, in the next lecture. Till then, keep watching CEC live lectures. Thank you.